Hi, in this video I would like to explain the principle of friction on an inclined plane. So take a steel block and pull it up an inclined plane. Take a rope and wind it around a pulley, and there should be a weight at the other end which is dragging the block upwards. And you can see that the little red arrows between the block and the inclined plane, those are the frictional forces. They act along the contact surfaces between the block and the plane. So the rope which is pulling the block up has got a white arrow next to it that shows the upward pulling force. The green arrow downwards is the weight of the block, and the pink arrow there is the normal reaction of the inclined plane back on the block. Let's look at a still image. The most important thing here is the mg, which is the weight of the block. That's the mother of all forces. So we must resolve that weight of the block into how much is the block pushing on the inclined plane, and we will come to the 2D resolving of that. The block then pushes on the inclined plane with a component of mg. The inclined plane pushes back on that block with an equal force, and that pushing back force is the normal reaction, which is here shown as n. It's very important to get the normal reaction right, because the frictional forces, those little red arrows, are directly related to the normal reaction. We should not relate those frictional forces to the weight mg, although they could be indirectly related. Having got that clear, we should now look at a 2D analysis of how to resolve these forces. Here you can see the block from a side view, and first draw the weight downwards, the mg. The red line, that's the mother of all forces. Then you will notice that the angle of the inclined plane, which is shown as theta, let's say 60 degrees, will be equal to the angle between the weight line, which is mg, and the double-edged black arrow line. The black line is perpendicular to the inclined plane and passes through the center of the block. So these two thetas will always be equal. So if the angle of the inclined plane is 60 degrees, that small triangle will also have 60 degrees. Now that we have a triangle there, it becomes easy to resolve it, and the black arrow becomes mg cos theta as mentioned there, because no force here can be greater than mg itself. So mg cos theta is smaller, and that sounds okay. And the perpendicular in that small triangle is mg sin theta. Now take the same perpendicular and draw it from the center of the block. It is shown here as a red arrow, and that's mg sin theta, no different than that. The frictional forces, the little red arrows, are shown here as F is equal to mu into the normal reaction, and they are acting backwards. The normal reaction here is equal to the downward force of the block on the plane. Therefore, normal reaction is equal to mg cos theta. That's the most important thing achieved by resolving these things. Now, since the block is moving upwards, the pulling force is acting upwards, shown by the blue arrow, and all the other two forces, mg sin theta and F is equal to mu into n, are acting downwards along the plane. Therefore, we have a wonderful case for a free body diagram. So the resultant force is upward pulling force, which is towards the right, minus whatever is acting backwards, and that is F pulling minus mg sin theta minus of mu into n. That means mu into mg cos theta. Now the word about mu. If the block is not yet started to move, we have to put mu static. If the block is already moving, we have to substitute mu kinetic into this equation. That's all there is to this friction on an inclined plane. There's no need to remember these equations. And I hope that this video was useful to you. Thank you and have a great day.